are adrenergic drugs? Adrenergic drugs are used in emergency situations such as cardiac arrest, asthma, and other chronic obstructive pulmonary disease, that is COPD. So among adrenergic drugs, now we discuss about salbutamol. Salbutamol. What is other name for salbutamol? Salbutamol is also called as albuterol. It is also called as albuterol. Right. So, in this type of adrenergic drugs, beta receptors are important. There are two types of beta receptors. One is beta 1 receptors and beta 2 receptors. Beta 1 and beta 2 receptors. As we are discussing about salbutamol, which is a beta 2 receptor, in which beta 2 receptor is there. Therefore, salbutamol belongs to the class of adrenergic inhalants, selective beta 2 adrenoreceptor, which is used in asthma and COPD, such as coughing, wheezing, feeling breathless. The salbutamol works by relaxing the muscles of the airways into the lungs, which makes it easier to breathe. Of course, it is not a steroid one. Therefore, one can use salbutamol in emergency conditions like asthma. Now, we see the structure of salbutamol. Structure. So, what is the structure of salbutamol? Salbutamol looks like this. It has a phenyl ring, benzene ring. It has OH, CH2, OH, and now it has a secondary alkyl group, and a CH2, and now a tertiary amine group, tertiary butyl amine group, So this is what the structure of salbutamol or albuterol. Now we'll see the synthesis, how the salbutamol is synthesized. Now see the different reactions for the preparation of salbutamol. Synthesis. Please note down. So this is prepared from para-hydroxy acetophenone. I'm writing the structure. This is benzene ring, hydroxy group, and this is COCH3. So what is this? This is para-hydroxy acetophenone. Para-hydroxy acetophenone. When this para-hydroxy acetophenone reacts with the following, that is formaldehyde followed by dimethylamine and acetic anhydride. Intermediate is obtained. So the intermediate will have such a structure where one of the hydrogen of this particular OH group is replaced by COCH3, and another substitution at the second position here CH2O C double bond O CH3 substitution takes place. And at para position we have C double bond O CH3. So this is the first step where the para-hydroxy acetophenone is converted to diacetyl substituent upon reaction with the formaldehyde, dimethylamine and acetic anhydride. And now this will be brominated, treated with bromine. Only one of the hydrogens of the methyl is replaced by bromine, and now the resultant intermediate is so you see COCH3 acetyl group, and here CH2O COCH3, one more acetyl group, of course benzyl. Here C double bond O is there, and CH2, one of the hydrogen is replaced by bromine. This intermediate is formed. Now this particular intermediate is treated with a reducing agent like sodium borohydride. When reduction takes place with sodium borohydride, this particular carbonyl group or this particular keto group is converted to the secondary alcohol. Only this particular carbonyl group is converted to the secondary alcohol. Therefore, the resultant product is and O, nothing will happen here. COCH3, this is CH2O, C double bond O, CH3, and this becomes as a secondary alcohol, keeping CH2Br as usual. So what is the product formed here? A secondary alcohol. Because salbutamol is a secondary alcohol. Now, this secondary alcohol is treated with benzyl tertiary butylamine. Now, this particular secondary alcohol is treated with benzyl tertiary butylamine. Benzyl tertiary butyl. So benzyl tertiary butylamine, of course, followed by hydrolysis. Now, the secondary alcohol is converted to the benzyl salbutamol. Benzyl salbutamol. See the structure. Here, this becomes OH. This also becomes CH2OH. Now the secondary alcohol will remain same, and this bromine is replaced by this particular group, and we'll have CH2 NH one side, benzyl group, another side CH3, CH3, CH3. So this is called benzyl salbutamol. Benzyl salbutamol. Benzyl salbutamol. So when this particular benzyl salbutamol reduced by palladium carbon and simultaneous debenzylation takes place and albuterol is formed. So when this particular benzyl salbutamol is reduced palladium carbon, here what happens? Here debenzylation takes place. Debenzylation takes place. That means this particular benzyl group is removed. Then finally we'll get the salbutamol. What is the final structure of salbutamol? So this is OH, this is CH2OH, and here CHOH, second alcohol group, that's CH2, here NH, sorry, here H will not be there, and NH, and CH3, CH3, CH3. So this is our final product. This is our final product, salbutamol. This is our salbutamol. So that's all about synthesis of salbutamol, which is started with the para-hydroxystoquinone treated with formaldehyde, secondary amine or dimethylamine and acetic anhydride, an intermediate with two acetyl groups will be formed. Of course, already one acetyl group is there at bottom. Treated with bromine, and this particular bromo substituent is formed, and it is reduced by the sodium borohydride, and now we will get secondary alcohol. And the secondary alcohol is treated with benzyl tertiary butyl amine followed by hydrolysis. We'll get benzyl salbutamol. Upon reduction with palladium carbon and debenzylation, we'll get salbutamol. So this is about synthesis of salbutamol. Now, what is the therapeutic action? Already I told you that this salbutamol is used to treat the asthma. Of course, it is used to relieve many chronic obstructive pulmonary diseases like coughing, wheezing, feeling breathless. So that's all about salbutamol. The next class we'll see about atenolol. So now we'll stop at this stage. Any queries?